Hello everyone. So this is going to be a video on the Königsberg bridge problem. So the city of Königsberg was located on the Pregel River in Prussia. So basically, city of Königsberg, that's and the Pregel River in Prussia, that's basically somewhere in Poland or Russia or something now. So the city occupied two islands plus the area on both banks. So these are the two islands, and these are the two banks, upper bank and lower bank of the city. Okay, so these regions were linked by seven bridges as shown below. So this is one bridge. This whole pipe sort of thing is kind of the river, and these are the seven bridges of Königsberg. So this is bridge 1, this is bridge 2, this is bridge 3, bridge 4, bridge 5, bridge 6, and bridge 7. So the citizens wondered whether they could leave home, cross every bridge exactly once, and return home. So I'd like you to, maybe you can like think about it, try to think about it, like can you do that? Like can you leave home and where you can go through here, you can go through here, probably here. Oops, I can't. I will have to cross it again. So not exactly once. If I want to go back here, and if I go here, then I haven't crossed this one. If I start from here and I want to get back here, so this would be maybe something, I don't know. Maybe you can go here. No, I don't think so. You'll have to cross it back again. So, so basically, it's not possible. So the so this can be modeled as a graph theory problem. So basically a graph is just a set of edges and vertices. So we can label these islands and lands as the vertices of a graph. Like this is W, this is Y, the island W, island Y, and the banks X and Z, the banks X and Z. So the model on the left makes it easy to argue that the desired traversal, basically we're just trying to find a traversal, right? Where that we leave home from one part of the land and we cross all the bridges just once and again come back to that point. So so it's easy to argue that the desired traversal does not exist. That's because each time, so suppose like the desired traversal exists. So basically, I think you must have observed by now, like what is happening. These are the lands and these are the vertices of my graph, and the edges are the bridges. Like this is one bridge. From X there are like total of three bridges. It's 1, 2, 3, and 2 to W and 1 to Y, and from Z there are again three bridges, 2 to W and 1 to Y, and from Y there's a bridge to W. So that's sort of my bridges as the edges. So and there are exactly 1, 2, 3, 4, 5, 6, 7, 7 of them. So suppose that a solution existed to this problem. Then what would happen each time we enter and leave a landmass? Like, don't imagine this. Like, just imagine if a solution existed. Then each time if we entered a landmass, like suppose we started from here and we entered this landmass, and you know and when we leave this landmass we would actually be using two bridges. We would use two bridges ending at it, like that are sort of ending at this vertex. So and so between, if we sort of started from here, then this would have two edges, two bridges connecting this with two bridges. And the thing is that we can also pair the first bridge and the last bridge on the landmass where we begin and end. So this can also be paired with two bridges, the one where we want to come back again. So thus the desired traversal would not exist, because then it would require, like what has happened now. So this is two, this is two, this is two edges, two edges as bridges, and this can be paired as like with two bridges. So it would require me to have an even number of edges, but this graph, it cannot have an even number of edges because the edges represent the bridges of Königsberg, and there are seven bridges, and seven is not an even number. So it is not possible for Königsberg. Thus the desired traversal does not exist because it must require an even number of bridges. And there's actually more about this. If you're interested, actually there's something like, I don't know, something about odd odd vertices, ending and starting at the same time, at the same spot. I won't go into that much depth, but I hope this sort of intrigued you. It's taken from a book, actually, Introduction to Graph Theory by Douglas. So I don't know if you get interested, if you find this interesting. I hope you like it.